Hello, my name is Soumya. I, along with my teammates, created a web page for searching evaluation. Here we have used a linear search and binary search for evaluation. This is a web page. Now let's see the code behind this. So to explain this code effectively, let me break down into smaller parts to explain its functionality clearly. So the first is a documentation declaration. This line declares the document type and version of HTML. In this case, we are using HTML5. It helps the browser understand and how to render to a page. Next line will have a HTML tag. This opens the HTML document and specifies the primary language as English. Next, we'll have head section where we'll have all the metadata related to the web page. Metadata provides information about a web page, but it is not directly seen in our web page. It helps search engines and browsers. Here, meta defines the character encoding for the documentation UTF-8, which is the supports most characters. Next, we'll have meta name, viewport width, the device width. This ensures that our web page is responsive on different devices, making it more mobile friendly. Next, we'll have title tag where we'll define our title of our web page. Next, we'll have link tag where we have linked our style sheet. Next, we'll have body tag. In this body tag, we'll have header which contains the main title and navigation links. H1 main heading of the page. Here our heading of the web page is search algorithms linear versus binary. Next we'll have navigation section with the links that allows us user to jump directly into the linear search or binary search sections. Next we'll have intro section. uh, the purpose of this intro section is it introduces the concept of search algorithms and sets the content of the section that follow. Here we have used h2 tag to declare the heading for our introduction. Next we have paragraph tag to display the introduction of searching algorithms. Next we'll have linear section where we'll have a code which will explains about the linear search. So we are using h2 tag to declare the name of the title linear search. Next I'm using paragraph tag uh, to give a small information about what the linear search is and how it works. Next I'm using pre tag. So to display as it is the text we'll use pre tag. So to here I'm using a pre tag to display the main logic of our linear search. Similarly we'll have created a section for binary search with id binary search, and we have given a h2 tag for the title binary search. Next I'm using paragraph tag to display us information about what the binary search is and how it works. Next I'm using pre tag to display the main logic of the binary function. Later our teammates will explain clearly about the algorithm and the code how to search linear and binary. Next we'll have footer section. The purpose of this footer section is to provide copyright information about the web page. Next we'll have script tag. The purpose of the script tag is to link the external JavaScript page that explains and demonstrates linear and binary search concept. Next my teammates will continue.
Now we have linear search, which is one of the searching techniques. Linear search, which is also called as sequential search, because this checks each element until the target is found from the given array or the list. So therefore, the linear search, which searches if the given element is present in the array or not, that has n number of elements and the index values which ranges from 0 to n. And since this linear search probability of occurrence of two cases. If the element is found in the array, it prints the index of the element. If the element is not found, it prints that the element is not found. So therefore, here we have a piece of code of linear search to understand it better. And here we have taken a function called linear search with parameters ARR, which is the array name, and target or the key value. And in the for loop, we initialize I with 0 and I, which has a range of I less than array length or I less than n, and I incrementing. So in the if block, where if a of I is equal to target, then we return I. If not, return -1, which indicates that the element is not found. Here, a of I is equal to target, which means it repeatedly checks each and every element from the array. I mean, if it is found, then it returns the index. If not, it returns -1. That's all. And binary search will be continued now.
Coming to binary search. Binary search algorithm is used to find the position of a target value within a sorted array. It works by repeatedly dividing the search interval in half until the target value is found or the interval is empty. The search interval is halved by comparing the target element with the middle value of the search space. Looking into the code, here we divide the search space into two halves by finding the middle index element or mid. Comparing the middle element of the search space with the target element, if the target element is found at the middle element, then the process is terminated. If the target element is not found at the middle element, then they choose which half to will be used for the next search space. If the target element is smaller than the middle element, then the left side, the lower side, is used for the next search space, or the key or the target element is larger than the middle element, then the right side is used for the next search space. This process continues until the key is found or the total search space is exhausted.
Now we'll be checking the working condition of the website. Like first, coming to the linear search, we'll enter few elements like 3, 5 and 7 and 9. Now for the target value, we'll be entering the element 7. Now let's check. Yes, the element 7 is found at index 2. So let's enter another element which is not given. Like let's enter 6. Run linear search. The element is not found. Now binary search. Binary search works on sorted data. So let's enter the elements in the ascending order, like 3, 4, 6, 8 and 9. Now let us enter the target value as 6. Now run binary search. As we can see, the element 6 is found at index 2. Hence this is how the website works. Thank you.